Hello everyone, welcome back to part 2 UV spectroscopy series. In the previous video, we have already learned how to calculate lambda max value for conjugated Dienes system. Today we are going to explore how to calculate lambda max value for Enones system. So stay tuned with Chem-O-Notes and don't forget to subscribe, like and hit the bell icon and share the channel to your friends. So let's begin. So as we have already seen in the first video or first part that the Dienes system we calculated using Woodward-Fieser rule. Okay, in a similar way we are going to calculate lambda max value using Woodward-Fieser rule for ion system. Now what do you mean by ion system? Let us understand first. Okay, ion system is nothing but it is having an alpha beta unsaturated carbonyl compound, meaning carbonyl group, that is C double bond O, is conjugated with a double bond. As you can see on the screen, there is a carbonyl. Let me show with the highlighter. This is your carbonyl C double bond O, and to the carbonyl there is a conjugated double bond. So this is one of the conjugated double bond. Then there is second conjugated double bond. So carbonyl is having two conjugated double bonds. Okay, this conjugation allows for strong absorption in the UV range. Because of conjugation, what happens? The absorption takes place very strong in the UV range. Preliminary due to pi pi, that is pi pi star and n pi star electron transition. So you will find that these are your conjugated double bonds which we can denote by alpha, beta, gamma and delta. Okay, the carbon which is next to the carbonyl, that is this carbonyl carbon, we will label it as alpha carbon, then beta carbon, gamma and delta. So these are the Greek notifications for denoting your carbons next to the carbonyl groups. So let us see the rule of Woodward-Fieser rule, in which we are going to understand the table first before calculating the lambda max value for ion system. Let us understand what is the base value. As for the Dienes system, the base value for lambda max was 215. Same way you can see here in the table the lambda max value for unsaturated cyclic ring is 215 nanometers. Then base value for cyclic 5-membered ion is again 202. Base value for aldehyde is 207. Then if there is extra double bond in the conjugation, then we will add 30 in it. Okay, similarly if there is a homoannular component, then we add 39. Then exo double bond, if it is there, we add 5, and additional 10 nanometer if the double bonds are in exo to 2 rings, which is similar to your Dienes system. Then the substituents which are present, like hydrogen, if it is there, we don't add anything, it is 0. But if there is alkyl group at alpha position, alpha carbon, then we add 10, beta carbon we add 12, and gamma and delta carbon we add 18. Okay, in the similar fashion for halogen, alpha carbon, if the halogen is present, then we add 15, beta carbon, if the halogen is present, then we add 12. In the same fashion for OH groups, you can see that for OH and OR, that is alcohol and OR groups, the values which are to be added to the base value is 35 and 30. Okay, if it is at alpha position we add 35, and if it is at beta position we add 30. Then similarly there is a ester group present at alpha carbon, we add 60, beta carbon we add 60, and gamma carbon we add 60. Similarly, if there is a ether group or O group, we add 75, OR group we add 85, and NR group we add 95. Okay, so this is a small table which you should remember, and as I told you in the Dienes system also, the more you practice, the more of the value you will recall them while solving the examples. Okay, so let us start. So this is the first illustration which we are going to calculate. Okay, so step by step we'll try to add the values for lambda max, and we'll try to calculate how much is the lambda max value. So let us start with the first example. Okay, in the first example you can see there is a Enone system, and in the Enone system let us first write the base value. Okay, so first thing what we are going to do is we will write the base value first. So base value is, as we have seen in the table, the base value for the Enone system is 215 nanometers, correct? So which is the Enone system? This is your carbonyl group C double bond O, then this is your alpha carbon, beta carbon, then gamma and delta. Okay, so you are going to see which are the groups attached to this and try to find out. Now for gamma carbon there is one CH3 group, so here your CH2 group you are going to highlight it. Similarly delta carbon there is one CH2 group, okay, which we have to add these constituents, substituents for in 215. Then let us write for extended values, extended conjugation. So extended conjugation, there are two extended conjugation, so we are going to add 30 to this. Okay, extended conjugation, if you see the table, you should take the screenshot of that table and try to write down in your notebook. Okay, so 30 is the extended conjugation you are going to add. Similarly, try to add one exocyclic double bond. Okay, one exocyclic double bond, this is a ring. To this ring if you find gamma delta double bond is your exocyclic, so you are going to add your 5 nanometers to this. Okay, and apart from that, two substituents which we have to add, that is your CH3 groups or CH2 groups. So two substituents, and these two substituents are at gamma and delta position, so you will be adding 10. No, for gamma and delta position, let us see, it is not 10, it will be, we have to see by which position these are. So it is at gamma and delta position, so we add 36 to it. Okay, 36 nanometer, 18 plus 18 is 36, so 36 nanometers you are going to add, and if you add them up total, you will find that it comes out to be 286 nanometer. So lambda max value calculated is 286, and observed, if you see the observed, when you see it with the machine, okay, instrument, you will get 287, so hardly it makes any difference. Okay, so whatever you are going to calculate using this Fieser's rule is same with the instrument which you are going to get. So let us go for the second one. Okay, the second Enone system, if you see, there is a Enone system. So in this Enone system you can find here the carbonyl group C double bond O, as you can see here, C double bond O, to its conjugation there is a double bond, then there is one more double bond, and this conjugation has been extended. You can find here, it goes like this. Okay, there is extension of double bonds. So let us write the label them. This is alpha carbon, beta, gamma, delta, and so on. You can have the extension. Now let us write down the base value first. So the base value here is 214 215, okay, 215 nanometers. Then we have two extended conjugations. There are how many? Two extended conjugations. Two extended conjugation, that is gamma delta and the next one. Okay, these are your two extended conjugations. So how much you will add? For one extended conjugation you added 30. So here it is two extended means 60 we should add, 60 nanometers. Then next is you have homoannular system. If you see this, that is your, suppose this is your first ring and this is your second ring. Second ring is homoannular. So for homoannular we add 39. Okay, so homoannular, you are going to add 39 nanometers. The next what we have one exocyclic double bond, that is this in your ring number 1. Ring number 1 double bond is exo to ring number 2. So one exocyclic double bond. How much you are going to add to this? One exocyclic double bond we add 5. Okay, so 0.5 nanometers you are going to add. Then next what else we have? We have one beta substitute. If you see the beta substitute, here is beta. So at beta carbon you have CH2 group. This is your CH2 group. Okay, so one beta, delta we have again a double bond. So you are not going to have that. And as it is delta substitute, again if you see, we are going to add this. So one beta and one delta. One beta substitute, you are going to add, for beta position we add 12. Okay, for alpha position we add 10, for beta position we add 12, and for delta and gamma position we add how much? Delta substitute we add 18. We add 18. So there is 18 nanometer. What else we have to add? Anything else we have to add here? No, there is no other substituent. So you will be calculating the total lambda max value for all these substituents which you have added, and 215 plus 60 plus 39 plus 5 plus 12 plus 18. So the total comes out to be 349. Okay, it is 349. So let me write it properly. It is 349 nanometers. Okay, so for this Enon system you can find that the lambda max value calculated is 349, whereas observed was 350. So let us go to the next example. If you can see the next example which is on the screen, the third one, it is again a Enon system. Okay, if you can see here, carbonyl group, and there is a double bond which is in conjugation with the carbonyl group. So let us write the base value. Base value is 215 nanometers. Okay, then is there any extension? Yes, there is. So you will find there is no extension here, as there is only one alpha beta unsaturation. Okay, there is no extension. So no conjugation extension, so we will not add any 30 nanometers in this. We are not going to add. But if you see, this carbon is your alpha carbon and this is your beta carbon. Beta carbon, there is a substituent, that is CH2 group here, and alpha carbon also we have one substitute. So what we are going to add? One alpha carbon substituent. Okay, alpha substitute, and we are going to add 10. For alpha, we have seen in the table it is 10 nanometers we have to add. For 1 beta substitute, you will be adding 12 nanometers. Okay, what else? What else we have to add? Okay, there is nothing we can add in this now. So we are going to just do the total of these three, and it is 215 plus 10 plus 12, which comes out to be 237 nanometer. So your lambda max value calculated comes out to be 237, whereas lambda max observed was found to be 232. Okay, 232 nanometers. So let us go to the next Enon system. So here you can find 5-member rings. Okay, there are two 5-member rings with a Enon system. So let us see. If you can see here, there is a carbonyl group, and in conjugation we have a double bond. This double bond is exo to both the rings. These are exo. This double bond is exo to both the rings, both 5-membered rings. So let us see how the value is going to change. Now your base value, it remains the same, that is 215 nanometer, correct? Then what else we have to do? There is a, okay, here one mistake what we have done is that the Enon system is 5-membered ring. So you have to remember that. Okay, for 5-membered ring Enon system, our base value is 202. What is our base value? It is 202. It is not 215. So here we are going to write 202 nanometers for 5-membered ring. 5-membered Enon system. Okay, 5-membered Enon system. This is the base value. Then what else we are going to add to this? There are two exocyclic double bond. Exocyclic double bond. Two are there, so 2 into 5, that is 10 nanometers you are going to add to this 10 nanometer. Then what else is there? Suppose this is your alpha carbon, this is your beta. So for alpha carbon there is one substituent, that is CH2 group. For beta there are two substituents. If you see here, for beta carbon there are two substituents, correct? So what we can do, one alpha carbon, alpha substitute, one alpha substituent, how much we are going to add, students? We are going to add 10 nanometers. And there are two beta substitutes. So two beta substituents. For one beta substituent, how much we add? 12. So here we are going to add 24 nanometers. So the lambda max value calculated comes out to be, yes, calculate this fast, students. 202 plus 10 plus 10 plus 24, and it comes out to be 246. Okay, 246 nanometers. So this is your calculated value for this Enon system. Okay, so if you are taken down in your notebook, let us go to the next one. Please do subscribe and like the channel if you are liking the video. The next one is question number 5. You can see a simple Enon system, 5-membered ring. So what you can write down the base value. Base value for 5-membered ring, we have already seen that it is 202 nanometers, correct? And this is your alpha carbon, this is your beta carbon. So for alpha carbon there is one CH3 group, this is your CH3 group. For beta carbon, CH3 and CH2. Okay, so there are two substituents. So in a similar fashion you are going to get this also, that is alpha substitute, one alpha substitute. So one alpha substituent you are going to get how much? 10 nanometers. Then two beta substitute, two beta substituent, so it will be how much? 24, 12 into 2 is 24 nanometer. And anything else we can add? No, there is a simple Enon system, so nothing we have to add to this. So if you calculate, it comes out to be, the lambda max value calculated comes out to be how much? It comes out to be 236 nanometer. Okay students, so let us see the next one, sixth one. If you see, there is a Enon system, carbonyl, then conjugated double bond at alpha beta. Similarly, there is gamma and delta also. So there is one extended conjugation for this system. So let us write down. Now this is a six-membered ring, or the Enon is six-membered. So our base value again it will change. Okay, how much it is, students, for six-membered ring base value? It is 215. Very good. 215 nanometers. Then there are alpha, beta. For beta, how many substitutes are there? This is one and this is second. Okay, 2 beta substitute. So 2 beta substitute. So for 2 beta substitute, how much you are going to add? You are going to add 10. For beta it is 12. So 24 you are going to add to this. Then delta, if you see, there is one substitute at delta. This is your delta substitute. And delta substitute, how much we add? For delta substitute we add 18, correct? We are going to add 18 to this. So just add 18 nanometers. Apart from that, anything else we can add to this? Just see what else. Yes, one more thing we can add, that is exocyclic double bond. That is alpha beta double bond is your exocyclic to your ring number 2. Suppose we write this as ring number 1. Okay, the Enon system, if we write ring number 1, this is your ring number 2. This is your ring number 3. We are not interested in the further rings, but ring number 2, if you see, alpha beta double bond is exo, that is exo double bond. So what you are going to write? One exo double bond we are going to add to this exocyclic double bond. Okay, add to it, that is 0.5. We are going to add to it 0.5 nanometer. Now if you calculate, anything else is left out? No. Okay, so that's all. Lambda max value calculated will come out to be how much? 215 plus 24 plus 18 plus 5. So it comes out to be 244 nanometer. Okay, so lambda max we have calculated using our Fieser's rule, Woodward-Fieser rule, where these are the simple way you can calculate the lambda max value. Now there is next one, that is seventh. If you see, there is a Enon system. Okay, so let us write the base value first. Base value comes out to be 215 nanometer. Let us label them alpha, beta, gamma and delta, correct? So alpha, if you see, there is CH3 group, beta there is CH3 group, then gamma there is one substitute of alkyl group, and delta there is one more substitute. So all these substitutes will get added. So before we add the substitute, see here, gamma and delta is your exocyclic double bond, correct, to ring number 1. So for ring number 1, your gamma delta bond double bond is the exocyclic. So let us add one exocyclic double bond, exocyclic. So it is one exocyclic double bond. So it is 0.5. Then what else? We have one alpha substitute, one alpha substituent. So how much you are going to add? For alpha we add 10 nanometers. One beta substitute. No, for beta if you see, there are two actually. this is one more. So there are two beta substitute. Okay, so beta there are two, that means 12 into 2 is 24 nanometers. Then what else? Gamma and delta we have 1 so gamma and delta substitute, so we can add directly, we can add 18 into 2. Okay, 18 to the 36 nanometers. So that's all. Yeah, that's all. So if you add all these together, you will find that the value comes out to be, okay, so here the lambda max value comes out to be 209 nanometers. Okay, so similarly you can solve the eighth one. So let us do it fast. The base value is how much? 215 nanometer. Then one exocyclic. For this you will add your 0.5. This is your exo. Let me write alpha, beta, gamma and delta. Okay, then what else? Alpha, beta we don't, okay, we have one substitute. Gamma we have one substitute, and delta we have one substitute. Okay, so total we have three substitutes. So beta substitute is 12. Okay, we are going to add 12 nanometers. Then gamma and delta substitute, we are going to add how much? Gamma and delta 1836. So here your value comes out to be 215 plus 5 plus 12 plus 36. Okay, so how much it is? So here the lambda max value calculated is 268 nanometers. Okay, 268 nanometers. And in this way you can calculate the Enones system lambda max value using Woodward-Fieser rule. Okay, so there are some practice examples which I have shown on the screen. Just try to solve them and try to comment me below whether you could solve this or whether you couldn't solve these examples. Okay, so you can just calculate lambda max value for Enon system is a simple, once you remember the base value and add the contributions or the substituents. And if you like the video, please like, share and subscribe, and stay tuned with Chemo-Notes. Thank you for watching. Keep practicing and keep exploring chemistry the smart way. So let me know if you want any other videos which I can prepare. Just go and watch our playlist for different videos which I have uploaded. Thank you for watching. Bye. Stay tuned with the ChemONotes, and please subscribe, hit the bell icon and like the channel. Bye till then.